Well, in this repairing video, we're gonna be working on this board, which came in from Kerala. So, customer told the board is not working, and please do the needful. And I can see nothing with my bare eye. So, what I'm going to do is just check under the microscope, and I have multimeter, and I have a thermal cam, and I have a DC generator, so that will be fine to identify whether the problem is here or not. So and problem is here actually, because customer already told they cross checked with another machine, and that board is working. So there will be a chances of any components damage or something. So here we go. We'll go to find the problem. And I am Praveen Rajagopal. This is Mr. Biomedical. So, in every SMT or SMBS board, you should know where to start. And the thing is so simple. Whenever you are starting with the board, you should start with visual inspection, like for any damaged components or missing components or blown components, or any corrosions, or any liquid damages, or any track failure. So there is so much of chances over there, so you should see visually, then only you can understand the PCBs. So this is a formula of every PCB, and I'm doing every time. So this is two-layer board, and one layer is here, you can see, and another one layer is here. So here having the microcontrollers, ICs, capacitors, resistors, and diodes, and LEDs, and inductors, and everything. And here I can see only capacitors and resistors. We'll see under microscope and what's inside, and let's see whether it will work or not.
So let's see. So this is a IC, and this is a connector, female connector, and this one is resistor. Let me show you. This is a series resistor, I guess, and this one is inductor, and resistor. This is a dip switch, and this resistor, serial resistor. Maybe it's fuse, I guess. Let's check with multimeter, so that I'll also know whether it's a resistor or yes, it's a fuse. No, it's not a fuse. First one and last one showing continuity, and another two is showing no, it's a fuse only. Yeah, it's a fuse. So if a maybe, and then I'm searching for broken components or blown components, but here caps fine, and resistor is fine, IC is fine, capacitor is fine, inductor is fine, resistor is fine. I can't see anything obvious till now. Maybe some corrosion here, but that doesn't matter, it's still in track, so don't worry about it. Resistor is fine, and IC and IC legs are fine. Here also fine, and here inductor, capacitor is fine, comparator is fine, so everything is fine. Opposite side, capacitors is fine, resistors is fine, capacitors, okay, absolutely fine. So what I'm going to do is just check with the multimeter and see whether we have a clue or not. So I'm taking my multimeter and put the multimeter into continuity mode, so that you can understand if there is any chance of short or something. So now it's in continuity mode. I'm checking it one by one. So whenever you are check, now it's showing 1.259, which is good. Oops, oops. This one is inductor, fine. Oh, this capacitor not fine. 20.8. 20.8 means it is a half short, and here 20.8 same. So this is also had a half short. So here nothing. Here 21.6. Here 20.8. Here 20.8. But this color is changed. I don't know why, but these three colors are same, but this capacitor color changed by any type of heat or something. I am suspecting this gap, uh, but let me check. We will do with one thing. We can do with the voltage injection here, and then we can see where the problem is. So if the problem is found, we can have a same capacitor, and then we can proceed further. So now the question is whether we can do or not. So we can find this the problem or not. So let's work on it. Yes, yes, this one is 0.4776, which is absolutely good. This one 20.8, 1 2 3, and here and here, one, no, here, no, here, 20.8. Totally 1 2 3 4 5 and 6, no, 3 5 capacitors showing short, but okay, this one also. So 6 capacitor showing short with a name with the same number like 20.8, which is not good. So we'll go directly for voltage injection and see whether it will work or not.
Okay, here the fact is what is already happened is 1 2 3 4 5 no 3 4 5 5 capacitors showing shorting, and this one also showed short. And the before injecting the voltage, we should know where we have to fix the negative line, because that is a major fact whenever you are doing the voltage injection. So here I am with negative voltage, and here I am with positive this one positive lead. So where we have to inject the voltage, that is a special point. So if you don't know where to fix it, then it won't give you the hotspot. So be careful on it, and once you done, you can easily find out the shorted components. If you're not placed the leads correctly, then what will happen is another components, any other components may damage by these voltages. So be careful whenever you are dealing with voltage injection. So now what I'm going to do is put the negative lead into any capacitor negative, because capacitor negative will be connected through the everything, because through the every components. So I can put my negative lead here, as you can see. And now what I can do is just give the positive lead to positive lead to any capacitor here. Okay, so I'm setting my DC power supply to 3 volt. So basically 3 volt is more than enough. Yes, your multimeter also giving the 3 volt to measure the diode values and capacitor values and everything. So it doesn't matter if you are choosing 3 to 5 volt, and I'm setting 3 volt here. So that will be more convenient for me. So now let's check with the voltage injection. And the point is, you should know where to put the positive lead. So that will make you to understand, or make you to have a conclusion with which is the shortest part. Okay, and I'm having my thermocam here, so I can monitor where the problem is. So that is another way. Okay, so now you can clearly see so what I'm going to do is just put the negative lead in any capacitor's negative line, and inject the voltage in here, so that we can find which one of this capacitor having short. So after that we can find out. First I have to fix the negative lead here, and put the positive lead here. Okay, so now it's a time to check. Yes, I have a heating spot from here, from that component itself, here itself. So unfortunately, I didn't have my rosin. So if I have a rosin, I can pinpoint where the problem is. So let's assume that this component, this capacitor having a problem. Okay. So will remove this and see. We will remove this and see whether the short is coming or not.
So first, we'll put some flux here. Okay, and then I can take my soldering iron and remove. Actually, it was the second one, which is getting a hot area. So I'm focusing on second. That's it. So if you think it's the hardest way, so then you should need experience. So these are coming by experience, not after seeing one board or two boards, not like that. There you should have some experience, practical experience, so that you can understand where the problem is and how to do that. Okay, now let's check again for the short. Now let's switch on multimeter, put it in the continuity mode. Okay, now check. Yes. Okay. Go from here. 0.109, which is good. 0.109, which is good. And here also no short. And here 0.412, which is absolutely good. My work is done. So as usual, we should clean the board. Where is it? So be careful whenever you are dealing with SMDs, because sometimes what will happen is overheated, or um, if you overheated or over pressed press this one, this some track, then it will move out. So it will make you a difficult point whether we have to restore the track. So that will be more difficult than it looks like. And now the problem is done, and we should check the capacitor's value, this capacitor's value, and put it here, because these four capacitors are also having the same value, so it doesn't matter. And I am going to measure this capacitor's value and put it here, then the problem might be solved. And customer, if you are seeing this video, your work is done, and I'll make sure that I will get this capacitor and send your board very soon.
So alright for now, and we got the point of where the problem is, and the bad capacitor can be changed because there is a four capacitors and four capacitors having a same value, so I can easily measure one capacitor's value and order two to three capacitors, and if it is coming, then I will fix it here and send back to my customer. So alright, that's it, and thanks for watching, and if you like this video, please like and subscribe for more videos, and we'll see you soon with another video. Bye.